Let's have a hands-on experience on using VPP Datapath with our Linux machine. Requirement is you need just only one Linux machine is enough. There itself you can create a 3-node Docker setup and test it. For this, we have steps to compile the VPP in Docker. If not, it is already available in the Docker Hub. We'll give you that. You can use that to create these Dockers. So Docker 1, this is router 1, router 2, router 3. This will be running VPP. This all three are in Datapath. So above that you can run any control plane. For now it is plain Linux. So now we will try to add static route and check whether we are able to ping between router 1 and router 3. So this is the configuration. How to make this configuration is you need to make a setup like this. That is VPP subnet 1 is a Docker subnet and VPP subnet 2 is another Docker subnet. So whenever you are creating any Docker subnet, that is Docker network, it will create a bridge, these two bridges. So now you have to start the Dockers. All the steps I'll give how to do. Initially all the three Dockers will be connected to the Docker 0. We have to move that and make a connection as we want. The VPP subnet 1 has its connection between router 1 and router 2. VPP subnet 2 has connection between router 2 and router 3. So router 1 and router 3 will be in 11 network and the others will be in 12 network. So this is the basic configuration which we are going to try now. Let's start how to do it. So you have, so this is a docker pull command, docker pull frr docker VPP latest. So if you just run this command, it will pull the docker image for you. This is based on Ubuntu 20. If you want, you can even compile it. I have given the steps in my YouTube channel. You can check that. So these are the dockers which we are going to use. So now, first step is to download and have this image. Second step is have 3 dockers opened. Start 3 dockers. This is the command to run the docker. So run docker VPP1 I am giving with that same docker image 1. Let this be router 1. Now this is the second docker which is VPP2. We are just running the second instance. Then comes the third one. So now we have executed all the 3 dockers. Now if you see in Docker PS, you should be able to see all the 3 dockers. VPP1, VPP2 and VPP3. As per this diagram, we have created all the 3 VPPs. So next step is we need to create this bridge. So now we'll see how is it already connected. VRCTL show. See, everything is connected to the Docker bridge 0. This is actually bridge 0. How to confirm is Docker network ls. So this is bridge 0. This bridge 0's IP only this Docker has created. If you see BR0, 172 network. So 172 network should be there in all the 3 host machines. We'll just confirm that. See, it is there 172. So now whatever packet you put in H1, it will be received in all the 3. So, but we don't want that. So we want a connection like this. So first we should remove from the Docker, from the bridge. So for that, this is a script we have written. Just docker exec -t. This one. What this will do is docker ps. It will just get the container ID of VPP1, VPP2, VPP3 using this command. Just it is executing and getting the host name alone. And we are passing and removing the extra spaces and giving a disconnect. So we'll try to run this command. If you just run the script, it's enough. It will just remove. Before running this, if you see this, all the VEs are connected. Now, once you run this, all the interfaces are removed. So the next step is we have to connect it. So how to connect? VPP subnet 1 is connected to VPP 1 and 2. The other is VPP 2 and 3. See, this is not there. You run this command and then see. So it is connected. So now if we go and see host 1, it should have a subnet with 11. We'll just see. This should be removed and it should be 11. It's 11. This is 11 and 12 because you have two connections. As per this diagram, you have two interfaces, ETH2 and ETH1. So here also. So now we are ready. Now we will see whether VPP is running. Actually VPP will not be running. So you have to start it in all the three. VPC, VPP, startup, and run it in the background. Same thing you can do in all the three. So now VPP is running. VPC. But there will not be any interfaces. Now we have to add interface. How to add is, we are not using DPDK here. It's just normal Linux circuit. So we'll see how to add it. I confirm that there is no interface in all the three routers. So now we'll try to create. Just quit and check this. So this ETH1. This ETH1 we are going to pull it inside the VPP. Like this ETH1 will go inside the Docker container. It will not be there in Linux. So how to do it is, first we'll remove the IP address of this. Remember the IP, it is 11.0.2. Removed it. Create host interface name. This is the command. We have to give that interface name. So that host interface will come inside this. So we have to set interface state host 81 up. So now the interface is up. Now we'll assign an IP. Set interface IP address host ETH1 11.11.0.2/16. The same IP giving. Show interface address. So now we are ready with the first node. The same thing we'll do in the other three nodes. Like ETH1 will be 11.3, ETH2 is 12. Just remember that. Both I am removing. ETH1 I am interface. Create host interface name ETH1 and same 2. So now two interfaces will be there. Set interface state host ETH1 up. Same thing we'll do for ETH2. So we have both. Set interface IP address host ETH1 was 11.11.0.3/16. Interface IP address host ETH2 was 12.12.0.2/16. Show interface address. So now we are ready with the second node also. We'll do the same in the third node. Create host interface name ETH1. Set interface state host ETH1 up. Interface IP address host ETH1. It should be 12.12.0.3. And just confirm and check. Now all three are ready. Now we'll check whether ping is working. Self ping will not work because it's a data path. Before ping, we can just check the routing table. So IP fib. So this is the routing table. Interface. Going to ping to the second node. H1 to H3. Is ping working? It's working. So now the same way we'll check here also in 11.11.0.2. This is also H2 to H1 is also working. Now we'll check from H2 to H3. It's working in H3 to this is also working. Okay. So now all three are working. Now if we see IPFib 11.11.0.3. How did it go? It will just clearly show us how it did. How the packet went out. It went through host ETH1 with this MTU and with all the extensions and everything. All this did. But still we want to know if we want to see the packet how it went, packet trace. For that we have a command called as we show interface also you can say how many packets has gone RxTX. But here trace you can give. I'll show it one node trace add AF packet input. Because it is not DPDK. If it is DPDK, then you should put DPDK input. This is socket. So we are giving here show trace. So nothing is there. Now I will ping to 11.11.0. After this, we will check the trace. So this trace shows that it is an AF packet. Ether input. What is the IP? What is the MAC? What is the destination MAC? What is the source IP? Destination IP? ICMP reply. It just shows everything. It has just received the reply. The other side, if you see, it should receive a request. It just reply to that. Now we'll clear it and we'll ping from the other side and we'll check. See, it has got an echo request. So it's working. So this is how they have made it work. But now we need to ping between router 1 and router 3. So for that, what to do? In router 2, we have 11.3 which is directly connected, but 12.2 will not work actually because there is no route. So it will say no egress interface. We'll check that. No egress interface because it does not know how to send it. So IP route, so IP fill, and you give the 12.12.0.2. So for this, see, this is the rule. It does not know where to send, so it just drops the packet. You can add an IP route. Add 12.12.0.0/16 via we should give the next node here reachable next hop, that is 11.11.0.3. 11.11.0. We have added this. So now see it says host, it has to send to host ETH1. Now we'll check whether it is working. So it's working, but it will not work for 3. That is the third node. Reason is there is no reverse route. To solve that, from first node we will try to ping to the second node this IP ETH2 11.0.3 from H3. This will not work. If we make this work, because this also does not have the same route, so we should add the same step as we did in H1. So IPFib 11.11.0.3. So for this there is a drop, so we should add IP route. Add IP route. Add 11.0.0/16 via this next hop. This next hop is 12.0.2. Now if we see if a bit is there, for 11 it has to work. Now if you put for 3 it will work. Same way here too. So end-to-end thing is working with normal static route. So instead of this, we can even have a control plane to resolve these routes for us that we can see in the later videos. For now, you can try this. It's very simple. You can just have hands-on experience. You can capture the packet and check all the data plane things you can explore. Thank you.